Your brain prepares a movement before you feel the choice. So when does your choice actually begin? In a lab, a bright dot circles a clock face. Electrodes record activity from your scalp and wrist muscles. You flick your wrist whenever an urge appears. Then you report where the dot was at that moment. The movement feels completely yours, but the timeline creates a problem. Electrical preparation begins before your reported awareness of deciding. That sounds like a clear verdict. Your brain chose first. But the experiment cannot prove that. In 1983, Benjamin Libet and his colleagues compared 3 moments. They measured scalp activity, muscle movement, and the participants' remembered urge. The activity linked with preparation appeared first. However, preparation is not automatically a completed command. You might picture a conscious commander giving an order and then your brain obeys it. Libet's result challenges that simple picture. The process may begin before you notice yourself choosing. Yet the early signal cannot reveal what was already decided, and it cannot show whether the movement was unavoidable. To understand why, you need to see how researchers created that famous rising line. The famous line was never one clear recording of one choice. In 1965, Hans Helmut Kornhuber and Luder Deek studied self-started movements. They recorded tiny voltage changes while participants moved repeatedly. Each movement produced a messy electrical trace, so the researchers needed a way to reveal any shared pattern. They used each movement as a common finishing mark, then lined up many recordings at that point. Finally, they averaged the recordings together. A faint pattern appeared. Electrical activity gradually shifted before the finger moved. This shift became known as the readiness potential. But averaging limits what that smooth line can tell you. Imagine drawing the same hill many times with a shaky pencil. Each drawing looks uneven, but stack them together, and their shared slope becomes smooth. The readiness potential works in a similar way. Its classic shape appears most clearly across many repeated trials. That makes it a pattern of preparation. It is not a decoded message saying, "Move now." It also cannot prove that one movement was already unavoidable. The early activity still matters. Its meaning is simply narrower than the headline suggests. Preparation has a measurable timeline. A private decision does not. That creates the experiment's next problem. Electrodes can time your hand, but how do they time a thought? Libet gave that invisible moment a position on a clock. You watch a spot circle faster than a second hand. You avoid choosing a movement time in advance. When the urge arrives, you flex your wrist, electrodes mark the activity across your scalp, while another sensor records when your wrist muscles activate. After moving, you recall the spot's earlier position. That position represents when you first noticed your intention. Libet now has 3 timestamps. One comes from the scalp, and another comes from the muscle. The third comes from your remembered experience. A millisecond is 1,000th of a second, while a blink lasts several hundred milliseconds. Libet divided an interval that brief into smaller pieces. On average, preparation appeared about 550 milliseconds before movement. Reported intention arrived roughly 200 milliseconds before movement. But those 2 times come from very different measurements. The preparation time comes from electrical recordings. The intention time depends on remembering a fleeting feeling afterward. Your attention may shift while the spot circles. Even the word urge may point to slightly different moments. That does not make the report worthless, but it makes the report useful and less physically exact. Still, another experiment appeared to push predictions several seconds further back. In 2008, Chun Seong-soon and John Dylan Haynes used a brain scanner. Participants lay still while letters streamed across a screen. They held one button beneath each hand, and whenever they wished, they pressed left or right. They also remembered which letter appeared when their choice entered awareness. This created a sharper question. Could brain patterns reveal the chosen hand before awareness appeared? A computer searched the scans for patterns linked to each response. It predicted left or right several seconds before the reported choice, but the prediction was weak, with accuracy reaching about 60%. Random guessing between 2 buttons would average 50%, so that result is better than chance. It is nowhere near certainty. The difference changes the entire claim. A weather forecast can lean toward rain without forcing rain to fall. An early brain pattern can also tilt the odds, but it does not prove the final press was locked. Keep that difference in mind. Prediction is not control. The pattern might show a slight bias or developing preference. It might also reflect background preparation. The scanner may catch a decision forming, not find it finished. And 60% accuracy means many individual choices were classified incorrectly. The machine cannot point at one trial and announce an unavoidable future, but this experiment contains another limit. Nothing important depends on either button. There is no reward, loss, promise, or person affected. That raises a more personal question. Does the same pattern appear when your reasons actually matter? Choosing where real money goes is different from twitching either finger. In 2019, Uri Maus and his colleagues tested that difference. Participants faced pairs of nonprofit organizations. During deliberate trials, their choice could affect where money went. During matched arbitrary trials, the options carried no meaningful consequence. The hand movement remained similar, but the reason behind it changed. That difference also changed the electrical pattern before action. The classic readiness potential appeared clearly before arbitrary choices. Researchers did not find the same classic pattern before deliberate choices. This does not place meaningful decisions outside physical brain activity. It shows something more careful. Results from random finger movements cannot automatically explain value-based decisions. Reasons and consequences change the process being measured. Awareness might also arrive while the outcome remains unfinished. Libet called this possible role a conscious veto, where you might feel an urge, then cancel or redirect the action. But stopping is still part of your brain's work. Awareness does not need to act like an independent commander, and it may participate inside a larger process already underway. That shifts the debate beneath the choice itself. What if the rising wave never marks a hidden decision? A later model offers a very different explanation. The rising line may not be a decision. Its smooth shape may come from averaging, so the curve can mislead you. In 2012, Aaron Schurger and his colleagues proposed another model. It begins with small background changes in brain activity, and while you wait, that activity wanders upward and downward. Most changes fade without producing movement, but sometimes activity reaches a boundary, making action more likely. Picture a cup catching uneven drips. No single drip commands the spill, but once water reaches the rim, another drip can push it over. The model treats self-started movement in a similar way. Now line up many simulated trials backward from each movement. Every trial contains a different jagged path, and then you average those paths together. A smooth rise appears. That is the counterintuitive part. The famous curve can emerge without any single trial containing it. No early moment needs to hold a finished choice. The line may reflect uncertain activity building toward movement. That overturns the simplest reading of Libet's result. It does not erase his measurements. The averaged electrical pattern still begins before the reported urge. Schurger's model changes what that order can prove. An early rise may show growing preparation, not a final command. Awareness can be one event within that continuing process. It need not arrive after everything is settled. Electrical recordings can mark physical timing. Personal reports can mark experience. Neither can place the whole meaning of choice inside 1 millisecond. The wave may not show your brain deciding without you. It may be the shape left when uncertain beginnings are averaged together, and that unfinished process is visible in an ordinary choice. Rest 2 fingers on a table for a moment. Choose nothing in advance, then lift either finger whenever the urge appears. You may notice a faint lean toward one side. Then comes the urge, perhaps a pause, and finally movement. Those stages can blur into one simple feeling. I chose. Now picture your thumb hovering over send. This choice carries a consequence, and your hand may be ready while the outcome remains open. You remember how the message might affect someone, so you change one word, wait, or close the screen. Feeling an urge does not force the next step. Your restraint is not separate from your brain's work. Preference, awareness, restraint, and action can form one unfolding choice. That is why these experiments leave both simple answers behind. They do not prove that awareness commands every action. They also do not prove that choice is an illusion. Preparation can begin while reasons and restraints still shape the outcome. Consciousness may participate without ruling from one perfect instant. No single millisecond needs to contain the whole of you. The real split was never between you and your brain. It was between an imagined commander and the many steps within you. You are not a spectator arriving after your life happens. You are part of the process through which a possibility becomes real. But what happens when your mind produces more possibilities during every conversation? If seeing more possible outcomes changes your choices, what does it do to friendship? Follow that tension in the video on your screen, then subscribe to Where Why Begins.